Thanks, everyone. Hopefully, you can hear me and see me. I'll be start with just introduction. This is number 68, if I count correctly. Today is November 13. I needed to push it from Tuesday to Wednesday. Uh, Usually, we do it on Tuesday uh, of the week, but this time I needed to push it in one day. Thank you for joining me. I'll be just give you the if you're new to the group or first time uh, attending the meetup, we are meeting every month, and really the idea here is to learn something new. And in many cases, I my goal is first you learn something new at the end of this 50-55 minutes. That's the first thing. The second thing is that not only new thing to learn, but something that you can actually use. So sometimes we'll bring uh, ideas and people that present and something that is uh, maybe in the future would be something part of the standard in the future. But uh, I am trying to at the majority of the sessions to have something that you can use today in your job or hobbies or anything. So that's basically my goal. So today we'll have a cppquiz quiz, just the regular one. We'll have just a single one. And I have a YouTube channel recommendation, a person by Alex. Uh, Dath- Dathskovsky. Hopefully, I'm not butchering his last name. So I know Alex. I met him in CPPCon a few years ago, and he's a speaker in many conferences, CPP North and CPP Now and CPPCon, obviously. So so we'll have recommendation on his channel. And then I picked something from the Art of Writing Efficient program. We'll talk about it in a second. If we have time, I'm going to discuss some tip about transparent comparator and operators that you should be familiar with. If not, that's good. You'll be familiar with that at the end of the session. Very important for performance wise, and also hidden bugs that you can avoid. Okay, first thing first, I my name is Kobe. You can listen to CPP cast episodes that I've been uh, I'm admitting people that I was a guest in, and also I was a reviewer on this object-oriented C++ book that I highly recommend. Dorothy did a wonderful job writing this book, and I was the technical reviewer helping her to modernize the book. So I mentioned Alex and his YouTube channel. Uh, Highly recommended. It's basically short, uh, few minutes, 5, 8, 10 minutes long. That's it. Uh, CRDP, Beatcast, Reinterpretcast, sorry about the typo, UBs, Launder, Smart Pointers, combo operators. You have about 10 dozen of sessions right now, and he adds every few weeks he adds a new one, but it's just interesting and short, and something that I recommend just to check out. Okay, let's do one fun quiz. So let me just stop sharing and let me share this one. The reason I like this uh, cppquiz is, first of all, there is a book that you can check out, CPP's Brain Teaser, which is great. By the way, it's fun. It's a fun book. The reason is that you can learn new stuff just by solving this quiz. There is an app for that, by the way. Also, if you're on the go and the web interface is not working well for you, so there is an app. Okay, CPP's 23. What is the output of this program? There is a student async that is using async policy. The lambda, which is the function that we going to run asynchronously, is throwing 0. Yes, you can throw an integer, and then there is a try and a catch. The try is doing f.wait. If it's throwing, you catch and std out 1. Otherwise, if it doesn't catch it, so it's only going to be 2. Otherwise, it's 1 and 2. Okay, what do you think is going to happen here? And this is not easy, by the way. A hint: f has also that get, so it has that get and that wait. And the idea behind that, you holding a future, the nice part about future, some of the functionality can propagate exceptions. So the question is, would this exception propagate if I do f.wait?
I think no, should be 2.
It should be 2. Yeah, this is correct. Okay, let me just, this is 2. And this is kind of a tricky one, since it's blocked until the shared data is state. To get an exception, you have to use that get. So that get is really great because it propagates the exception. You'll get the exception. So there is no exception thrown. The catch block will never be entered, and the program only prints 2. So that's the interesting part. Okay, let's get back to the main thing. Okay, so I'm always thinking about new ideas and things that I can share so people can learn new things. So this specific book was on my desk for a while. I was reading some and putting it aside and then continuing, and I decided to give it a try again, just because Packet sent me an email and to kind of review the book, just providing them insights about my opinion. And I said, okay, this is a good opportunity for me to just go through the book and maybe dig some, and just get some of the interesting part that I can fit into a few minutes, into like 35-40 minutes for this session. Fedor has multiple books that I recommend you to check. It has, I know Fedor, I usually meet him in conferences. He's very active. He's a speaker. He has few talks that you can find in CPPCon and all. And I met him almost 20 years ago in one of the first C++ conferences in the Bay Area. So this book is specifically targeting the domain of writing C++, efficient C++ programs. He starts with benchmarking, like how to benchmark and for loops, and what is, like, even going to the question of, should I use unsigned or signed integer when I do loop, and why to pick one over the other. So it is interesting. I would just say that the format of the code is a bit kind of not super readable, but that's something that I hope they can fix. I think they are looking at the second edition, maybe sometimes in the next few years. Um, but this edition, there's a lot of good stuff that you can dig from this book. So um, what I wanted to discuss, so there's a lot of things there in the book. Obviously, we cannot fit into the whole session, but what caught my eyes was design for performance. This is the 12th chapter in the book, and there are a few examples that I'm gonna show you about picking the right design for your program, for your API, with performance in mind. The domain itself is huge, so obviously we're not going to cover everything possible related to writing API and performance considerations, but we'll just provide few examples that you can use in when you write or think about when you write your own program. So this is basically what the chapter would discuss, and I'll provide you a few examples that we can also discuss if you have any questions. Okay, so first of all, this is a very important principle in API in general. You want to have a minimum information exposed as little as possible. You don't want to expose a lot of information. This is something that not really discussed in the book, but uh, I would say that having a getter that expose internal data structure is usually something that down the road would hurt you in the long term, just because it's really hard to refactor this kind of code. Example, if you happen to have a specific container that you decided to have as a member, let's say std vector, and you have a getter that returns the vector either by reference, const reference, by value, whatever you think about, uh, especially if it's a reference, then this is part of the contract, and change and your clients might rely on that information. So it's very hard for you to change it in the future. So there are few ways to avoid that. You can provide, we discussed that last time, an iterator. We actually discussed that exactly this thing last time. We can have an iterator pattern, uh, and different, like a proxy is another thing. Obviously, you need to make sure that nope, if it is in the uh, critical path, you want to make sure that it has a low overhead, but that's something that is probably obvious. The contract is basically the interaction between components. Um, you want the contract to be, yeah, someone raising is,
All right. How about span? If he like want to
yeah,
not return the vector.
yeah. This is actually a good idea. This is what I'm using, uh, because that's like the minimal thing. Uh, you have a pointer and a length, and that's it, right? And you can iterate over that. And span is a great idea. Yeah, span string view is for strings, but span is a great idea. I agree. I'm actually using it quite a lot now. Thank you for mentioning that. Um, there's always tension between performance and design. This is obvious. When you calling an interface, you need to provide the maximum information that you can provide the callee, because you want the callee to have enough information to do whatever it needs to do. That's basically the opposite of the minimum. Like the minimum is like, I don't want to expose, but when I need someone to fulfill something, I want to disclose as much as possible. So here's an example that the first example that we have from the book. Think about this subscript operator. Uh, it can be a great interface, but not always. It depends on the context, and I'm probably gonna repeat that. It really depends on the context of the callers, like what the callers need. So here's an example. The subscript operator looks good, right? There's a lot of power, but do you really need that? So um, let's think about let's think about std_q. And if you understand what std_q is, it's double-ended queue, right? Uh, if you know what std_q is all about, you probably know what I'm actually going to mention. So it is block based, right? And using subscript operator means I need to recalc the the location every time. Is it efficient when I need to iterate over a specific chunk of the container? Uh, Maybe it's efficient in one cases, but it's probably going to be inefficient in lots of cases. Um, so here's uh, so here's a benchmark. So the benchmark has two things. One is using an iterator. So you have a container and you just iterate over that. But you can also have the index operator, like the subscript operator. Okay, so here's one benchmark that just iterate over that, and so you have a DQ, and we just iterate over that with the subscript operator. But the next one would be uh, using an iterator pattern. So iterator pattern doesn't tell the caller that there is a subscript operator. It's just a way to traverse the container. And here's the result. Here's are the results, and you can definitely see that the iterator is by far much better. Um, just want to make a note that this is a specific implementation that works well for this use case because we picked std_q. Um, but it can be a subscript operator might be faster different in a different uh, scenario or context. Uh, the nice part here is that both of them would when the block is contiguous, there is a contiguous memory. Both the index and the iterator they gain from this for this information, but the index we need to recalc every time, like which block we need to jump, and this is not the best API when std_q is involved. By the way, I had uh, I had a use case long time ago when I was playing with uh, qsort, like quicksort, and I play with taking a C implementation of quicksort and making it kind of a modern using. By the way, eventually I ended up using span, and for some reason, and I work with uh, uh, Turner, Jason Turner, on that, and he was the one suggesting, hey, you should use an iterator, not subscript operator. It was just vector. For some reason, I don't know why, the compiler was doing much better in generating code when it was an iterator. It was just faster, and the code was generated. The generated code was different. That was a long time ago. It was a couple of years ago, at least. Um, but it was kind of interesting to see that it's not always the same code that is being emitted. So just I don't know if newer compilers would have different behavior, but I did see that uh, difference. And by the way, the C++ code was fast, at least as fast as the C code, if not faster. Okay, here's another example, and this example talking about I have a set of t pointer and some compare function, and I have values stored in a container, uh, a vector in this case. So this is what we see here. So when I insert, so this is the compare pointer, uh, because we need to dereference. We're not comparing the address of the pointer. We need to dereference. But always remember that, by the way. That be very challenging if you don't understand like why the comparer is not doing the right thing, because comparing pointers are not what we're pointing to. So anyway, we have a compare, function, and this is the insert. So the insert is basically taking the t, pushing it there, and then inserting that to the set. Okay, just ignore like exactly like what is the context, because that's not important. Um, so let's see what's happening here. So um, let's say we this is part of this index tree. Okay, so let's say that this index tree has an iterator. So I have a way to iterate over the index, and the index, if you remember, is the set. Okay, so I need to iterate, and I have a requirements that I want to find a specific item given a function or predicate. So if it was just if it was just a a value in the set, so that's easy, but not it's a uh, log n. That's easy. It's a balanced tree, but that's not the case. I need to apply an f function, like a function f, on when I iterate and say, okay, oh, I found that, return true. So I'm going to do two things. One, I'm going to provide you a find function. It's a non-member one, where you provide me the container. The container has an iterator interface. So basically, the container has not the container, but the class has an iterator interface, and the iterator interface in this case is iterating over the set, which is great. It's a great interface. You want to iterate over the set. You're not exposing that you have a set. You're just exposing an iterator. We actually discussed that last session, and this is another example that people actually using it. Like this is something that I wasn't aware of, this example, when I was building the session last month. So here's a good example. Someone is providing an iterator pattern in their class. So one is a non-member function, and then the second one is, so just imagine index 3 has a member function that takes f, and since it's a member function, unlike the non-member function doesn't know anything, right? I'm just getting the function and the container, or the class that I can iterate over in the function. The member function actually is aware of the internals. So when I say find, just find not f, but with the function, and the function is doing something. In if I found it, I return true. Now, if you notice, I'm actually iterating over the data here. So if you go back, the data is a vector. It's not a set. So we provide two things. One is a non-member function. It's a generic one, takes an iteratable object and a function, like a predicate. And the second one is a member function that is aware of what's actually happening. Results are obviously going to, like, the vector is going to beat it like by far. Cache friendly versus not something which is not cache friendly. You can see the diff between these two. So first of all, I don't know if this is well known, but I've seen that once, that if you have a type and you can use non-member function versus member function, the member function might perform better. than the non-member function because it has more information. Now, the non-member function has its merit because it's a generic one. It can take, sometimes it's a template, it can take anything, so it's a non-member run. Sometimes it's equal. Like for example, this stud begin and dot begin should be the same because the stud begin just forward that to the container dot begin. So I don't think that would have any difference. But in this case, it's similar to other use cases in the standard template library where you have a member and non-member. So the member might perform better. So this is something that I realized sometime back in my career, that because I always have these two options, like use the member or not member, like dot find or just stud find. The dot find might perform better. Okay. Another thing that related to API design and concurrency in this case. So a few months ago, I talked about policy-based design. I don't know if you remember. Basically, Andrei Alexandrescu has this modern C++ design book from beginning of 2000, like 2000 and I don't know, 3 or 2, I can't remember. So his first or second chapter from the book talks about policy design related classes. So this is going to be similar in some sense. So let's say I have this index tree, the one that we had before. I want to have the insert one protected. So I want to have a log guard with a mutex. Here's the mutex. But what about the case where I don't want to lock because I know that I'm not in a multi-threaded environment or use case, or I know it for sure. So it is designed for that. One option is a runtime Boolean. So let's say you have a class that you define, named optional log guard. It takes a Boolean lock, and it's either basically RAII of either M or null pointer, and inside it can decide if the Boolean is true, then you lock. Otherwise, you don't, and there's a lock and unlock. So obviously, you can use optional and something with unique pointer, but it looks cumbersome, and also you can roll out your own optional log guard, just like you have here. It's a simple RAII that is similar to log guard, but it's a runtime. It's going to choose whether or not to lock it with an if. There's another option, obviously, which is using policy-based design. This is what I was mentioning before that you can use. So you have this index tree, and you have this lock policy, LPS lock policy that have lock and unlock, and you have a log guard templatized on this lock policy. Now, the idea here is that you can instantiate it with something that actually does lock and unlock, taking a mutex, or you can have a null object, which the lock and unlock are no op, they are empty. This is kind of a null object pattern that you might be familiar with. It's being used in policy, it's being used in strategy, also like runtime strategy pattern. So here's these two locking policy. One is doing lock, one is a no op. By the way, this is just make sure that you understand this kind of no op or null object. It's very useful in a lot of use cases when you design your systems. Okay, so you have strong this was TS. I remember. I forget, like thread safety. Yeah, you have strong thread safety and a weak thread safety. Thread safety tree. One is with, and it's all templatized. It's all compile time. So um, you don't pay the if here, which is much better. But you need to know that this is what you want in compile time. There is another option that is mentioned, which is a locking decorator. So you have uh, a weak thread safe, a weak thread safety guarantee. So uh, the the strong one is provided by a wrapper one. So this is where the decorator kicks in. Uh, so the, think about uh, a log a log guard that takes a mutex, and log tree is basically index tree uh, is the parent one. So you basically have your index tree, which is the regular one, and then you decorate it with an inheritance. Inheritance is not the best approach in many cases, but it makes it easier. So the excuse that the book is having here, because this is at least it's a private inheritance, right? So it's not convertible, so you don't need to have a virtual destructor on the base. Uh, Encapsulation is generally preferred, so either composing is better. The advantage of inheritance here is you can avoid copying all the constructor or having disusing statements to bring all the constructors. Actually, it's actually done here. This using index tree is bringing all the constructors in. So uh, it's just easier than basically implementing that and forwarding that to the one that you aggregate. So it is a simple approach. Um, just be careful when you do inheritance. Just minimize that as much as possible. This might be justified in this case. Okay, the last couple slides before we go to the other topic that I had is redundant getter and setters. So first of all, getter and setters should be used in a very specific use cases or specific. uh, I actually see them being overused in a lot of code bases, especially when you see a lot of like a huge stack and there is a getter for each of them. There is no really point in having that. It doesn't provide an more information. Um, there is one chapter in Beautiful C++ that I highly recommend you to go and read. It would give you a lot of knowledge exactly on that of getter and setter. So the guideline says that you should avoid that because it doesn't. It just it's just a cognitive burden on the reader of the class, the user, the client of the class and it doesn't provide anything useful. Now, so this is so just go and read this chapter on Beautiful C++ book because it is interesting. The one maybe use case that it is useful depends on you don't really have just a getter and setter just simply returning something which you have in your as a member, but you have a getter and setter that are extracting something maybe from memory, maybe from database, maybe from other. It's not a simple one. It's basically reaching out to some other mechanism. So this is where it is justified because there is something, there is another layer in between that does it. It's not just a simple okay return X. So this is something that is useful and you should use it, but do not design your API like this because it's not a good It's not a good idea. You basically want to break that maybe to just a struct of X, Y, and Z and color and just pass it around. There is no value in having that. And just aggregate the struct, compose the struct, and make sure that invariant works, like X, Y, and Z needs to be with specific values. Maybe there is a min and max. This is where you want to do that. Uh, Obviously, if you want to do some checks or more actions on the get and the set, then yes, then the getter and setter might be justified. But just plain return X or assigning to X is not a good. It's not a good API. So you should avoid that. And this is an example of something that might be justified. Okay, so the last 10 minutes, I'm going to talk about transparent operator. I don't know how many people are familiar with that. Uh, there's a lot of things related to this specific topic. I'm going to show uh, one specific aspect of it that I just happened. I think it was like a month ago when I was thinking about the session. Something I don't remember exactly, but something in my day job triggered this. Oh, this is going to be an interesting thing to kind of share with others. So let's talk about it. So first of all, transparent operators were introduced in C++ 14. I'm going to admit that I didn't fully realize how useful they are when I was first introduced to that. Um, I think it was right after the standard. I was participating in one of Scott Meyer's uh, workshops, uh, and he presented that towards the end, and it was kind of going over my head. Uh, there are some Stack Overflow related questions that you can read more, but I'm gonna give you the gist of it. So why it's important? What is all about C++ 14 transparent operator? So imagine you have a less than operator. So you have multiple options to implement and use this less than. It's a compare function. This is basically with stood forward and all. You can ignore that. The important part here is because it's a template. Uh, Less than has something less than something. Just return something less than something. This is one option. It's just a function. You can have a functor. It's a stock that has this parent operator that can be used in a container. Like you can instantiate that. Like the container is instantiated as a you pass it as a template type, template parameter type. Um, so there are two options. They are very similar. And obviously, oh yeah, you can also have a lambda. It's also an option. It's a good option. You have auto. This is a polymorphic lambda that was introduced in C++ 14. It looks verbose because so you have this vector and you have this option or the other option, which is a lambda. They are verbose, and uh, there's a different way to do that, especially if it's a stood less than. So first of all, you have stood less. The proposal allows us to do the following. So stood less, you instantiate that because it's a struct. Stood less is a struct, and if you notice, I don't have any template parameter into the struct because the struct has a default template parameter which is void. And the idea behind it is that when there is a specialization for this struct, when it's void, it's basically going to use the template type of the, let's say, the container here, which is v. Let's say it's an integer. So this is the important part. Why it's so important? Uh, okay, so this is, I don't know why it's doing that. Let me just try to fix it. A second. Try to fix it because it's overriding. Okay. I need you to read the. Okay, slideshow. Okay, you should see that now. Okay. Um, so why this is cool? Look, why not specifying the template parameter and letting the compare function? I don't know what happened. Ah, letting the compare function uh, take it from the container itself. Imagine you're not doing that. You actually either have your own operator parent for the compare function, or you basically specify I'm gonna have a, a std-less of a specific type. You have a vector of uint32, so your compare operator is going to be uint32. You change it to uint64, but you're not changing it either in your compare operator or you std-less, and you end up with uint64 truncated. And this is a very hard to find bug. So this is why having something which is having the transparent operator that takes the type from the container is has a lot of benefit. I lost the second. It's funny. I lost the. Oh, here it is. Okay. So so what's happening under the hood? So this is what you should be aware of. So this is structless. It has T, but void is the default, and there is a specialization of if it's being used as void. That so this is type def unspecified is transparent, is something that it's kind of a tag that tells, okay, this is a transparent operator. And uh, there is more. If you just Google for transparent operator, they were more were introduced in CPAPA 17 for more containers, which is important. So you should use it as much as possible, not to specify, but let 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 it being forwarded as needed. Uh, and this is basically from CPP reference, where you can see, okay, this is the is transparent. So is transparent is basically kind of a tag that tells us that this is a transparent operator. And I encourage you to, I'm not showing that today, but I encourage you to look at, okay, let me find that. I'm gonna, okay, so CPP stories. It calls also heterogeneous lookup. So 17 and 20, so 20 added more. So I'm gonna just paste it to the chat because it is interesting. But you're gonna find the chat here. Here. So this is one. This is heterogeneous for CPAS 20, where unordered map, unordered set were introduced, but he has also, when I say here, it's Bartek. He also has the one, to look for the one that has the heterogeneous. Oh, here it is. Okay. For CPAS 14. So you have 14, then 17 was introduced with the unordered one. So I'm going to paste it also. It's super important to understand that because this has direct implication on your performance. So take a look at these two links. Use the Discord if you have any questions. That's it. what I had for today. Hopefully, you learn few things, new things about C++. You have any questions? No? Okay. Thanks for joining. Thanks for coming here to the meetup. See you next time. Have a good rest of your month. Take care.